Welcome to this video on logarithmic functions. Let's begin. The objectives of this video are first to convert between logarithms and exponents, 2 to evaluate logarithms, 3 to use the ability to convert between logarithms and exponents to solve basic logarithmic equations, 4 become familiar with the common logarithm and the natural logarithm, and 5 to graph logarithmic functions. Before I continue, I need to tell you what I'm talking about when I say logarithmic function. So here's the basic definition. Notice we have to constrain some of our variables. It says for x is greater than 0. In other words, x can't be equal to 0 and it also can't be negative. Also, b has to be positive. It can't be 0, it can't be negative. Also, b can't be equal to 1. So this says that y equals the log base b of x if and only if x is equal to b to the y power. Okay, so these are equivalent expressions and they are inverses of each other. So let's see if we can map these and also define these variables. So let's start with b. b, as you can see from the exponential form, is the base. Okay, so when we're writing this function in exponential form, you can see that b is the base of the exponent. When we write it in log form, you can see that it's a subscript. We say, the way we read this is log base b of x. Okay, so now let's look at y. What is y? Well, y is our exponent. Okay, so y equals the log base b of x. So here, y is on one side of our equation. Over here, okay, when we write it in exponential form, this is our exponent. Okay, so what about x? What should we call x? Well, if we look over here, right, x is the result, isn't it? X is what we get when we take our base and raise it to the exponent. So you could think of it as the result. Okay. Now, if you read a math textbook or something, you might end up, you might see that they call this the argument. Okay. And the reason is that anytime you have any function, whatever variable or expression is inside of it is called the argument. Okay. So you can call it that if you want. You can use that word. To me, result, right, is just so much more helpful and gives you more insight into what we're talking about when we say, when we're talking about bases and exponents, right? So I have a base b, I raise it to some exponent y, whatever that is the result, okay? So this is a little bit, first of all, it's very theoretical, right? Because all of these are variables, not numbers, okay? And also, you might be thinking, well, what is this log business over here, right? What is that? Where did it come from? So let's see if we can explore this idea a little bit more and try to make a little bit more sense of it. Exponential and logarithmic functions are inverse functions. In other words, to undo an exponential function, we can use a logarithmic function and vice versa. Let's revisit some familiar functions and their inverses to better understand the relationship between exponential and logarithmic functions. So let's start with addition. So if you look at addition, right, y is equal to x plus 3. Remember, the inverse of addition is subtraction. So how do we undo this plus 3? Well, we simply subtract 3 from both sides. So if I rearrange this function, I would just get y minus 3 equals x. Now, y minus 3 equals x is not the inverse function of y equals x plus 3. In fact, it's the same function, it's just moved around. So we don't actually get into finding inverse functions in this course. If you want to learn more about that, you'll have to take the next course in our sequence. But for right now, again, I just want you to see that we're moving things around, we're rearranging them, and that's exactly what we're going to do when we get to exponents and logs. Okay, let's keep going. So now we have y equals x minus 3. Well, how do we undo minus 3? We simply add 3 to both sides. So we get y plus 3 is equal to x. Again, this function is the exact same function, it's just been rearranged. Okay, now we have y is equal to 3x. How do we undo multiplication? Well, we simply divide both sides by 3. So the same function rearranged is y divided by 3 equals x. Now we have multiplication. I'm sorry, just kidding. We have division. Right? We have y equals x divided by 3. How do we undo a divide by 3? Well, we multiply both sides by 3, or if it makes you happy, think about multiplying by 3 over 1. So then what happens, right? These 3's go away, so we find out that we have 3y is equal to x. Again, y equals x over 3 is the same as saying 3y equals x. They're just rearranged. All right, so now we're going to get into something a little trickier, right? We have power. So we have y equals x to the third power. How do we undo the third power? Well, you might remember we take the third root of both sides. So this equation rearranged is the third root of y equals x. Again, y equals x cubed and the third root of y equals x are saying the same thing. They're just rearranged. Okay, let's keep going. So now we have y is equal to the cubed root of x. Again, we undo this one by raising both to the third power. So we rewrite this as y to the third power is equal to x. Okay, so now here's where we get into exponential functions and log functions. So I want to ask the question, I don't know if you've thought about this before, but we do have an exponent here, just like we had here, right? Why can't I just take the root? Why can't I just take the root of this and the root of this? I want you to pause this video and really think about that question. Okay, so what root would I have to take if I'm raising it to the y power? Well, wouldn't I have to take the yth root? So what does that even mean, right? How can I take the yth root of something? Because y is a variable, right? The only way I can take the root, or that I ever have taken the root in the past, is when it was just a number or a constant, right? But we're in a bit of a pickle here because this is not a constant anymore. It's not a number. It's a variable. So how on earth could I possibly do that, right? So I can't. Okay, is a simple way to explain it. So somebody a long time ago invented this idea of a log. Okay, so this just says that we have the log base 3. Okay, so we use our base of x. That's our result is equal to y. Okay, and log, it's really just a man-made convention. It's invented by humans, okay, to express the idea that when I take the log base 3 of x, I get y, okay. Again, they're exactly the same thing. This guy and this guy are expressing this exact same concept, right? They're just the same thing rearranged, okay. Likewise, if I have log base 3 of x equals y, I can rearrange that as 3. Remember, 3 is my base. Y is my exponent. 3 to the y power equals x. That's my result. Okay. So again, I know it's a little bit tricky and confusing, right? Because you might be arguing, well, wait a minute, in all these other functions, I didn't make up a new function, did you? Well, you kind of did, right? If you think about addition, right? We didn't have subtraction. Right? Addition and subtraction are different operations, right? So we had to, if you will, invent a new operation in order to undo it, right? When we were doing multiplication, right, the only way to undo multiplication was with a new operation, which is division. If you think about powers, right, the only way we could undo a power was with a root. It's a completely different operation. So it kind of makes sense, if you really think about it, that we have to invent a new operation to undo an exponential function, which is the log. So let's look at the log base 2 of 8 equals 3. So this concept, I think, is much easier to understand when we actually put numbers into this context. So let's go through and label these values. So remember, this number down here in subscript is our base. Okay, and you might notice I put a number line down here because I'm going to bring back our exponential or logarithmic scale. So as soon as I know my base, I can fill out this number line. Okay, so remember, we're not counting in a plus sort of way, we're counting in a time sort of way, right? So every time I move from one number to the next number, I am multiplying by 2, right? And when I move in the reverse direction, right, I'm dividing by 2. So that is the pattern here. Okay, and then let's just fill out the values. Well, 2 to the 0 power is 1, 2 to the first power is 2, and so on and so forth. Okay, so then 2 to the negative first power is 1/2, then we have 1/4, we have 1/8, and we have 1/16. Okay, so the base already has given me this nice logarithmic scale, right? So I can see what some of the values are. Now, obviously, you know, it goes infinitely in both directions, right? So I don't have all the numbers here, but hopefully, maybe I have the right number. Okay, so what did we call 8? Do you remember? So we called 8 the result. Okay, so the way I would think about 8 is it's where on this number line we want to land. So can you find 8 on this number line? Well, it's right here, isn't it? Right? This is 8. This is where we want to end up. Okay, so what does 3 tell us? Well, 3 is our exponent. Remember that, right? But basically, it's the number of times from 0 that I had to move, in this case to the right, because it's a positive 3, in order to get to 8. So let's count. We had 1, 2, 3 times, right? So from 0, I moved to the right 3 times to get 8. Another way to say that is that I had to multiply 1 by 2, not once, not twice, but 3 times in order to get to 8. Okay, so let's practice rewriting log base 2 of 8 equals 3. Let's practice rewriting it as an exponential function. So 2 is my base, 3 is my exponent, right? And 8 is my result. 8 is where we want to land, or where we want to get to. Okay, again, saying log base 2 of 8 equals 3, that is equivalent. It is an equivalent expression to saying 2 to the third power equals 8. Okay, it's just the same as, right, if I said 4, let me pick a better number, right? If I say 8 divided by 2 is equal to 4, right? That's giving me the same pieces of information as saying 4 times 2 is equal to 8, isn't it? The only difference is it's rearranged, right? One of them contains division, one of them contains multiplication, but they're kind of the same fact. They're the same math fact. So in a similar way, log base 2 of 8 equals 3 is giving us the same information as 2 to the third power equals 8. Okay, let's try to do another example and see if we can make more sense of this. Okay, this time I have log base 3 of 1/9 equals x. So let's review. Remember, 3 is my base. Okay, as soon as I have my base, right, I can fill in my logarithmic scale. So I put 3 in all of these numbers, right, because 3 is the base here. Okay, and then I can take a minute and fill in these numbers. So we have 1, 3, 9, 27, 81. Going the other direction, we have 1/3, 1/9, 1 over 27, and 1 over 81. Okay, so now we're given this 1/9. What is 1/9 telling us? Well, 1/9 is telling us where we want to end up, right? So where do we find 1/9 on this scale? Well, isn't it right here, right? So x is going to be the number of steps that we have to take, and it's going to tell us also in what direction to get from the number 1 to 1/9. Well, to do that, what do we have to do? We have to divide by 3, not once, but twice. Okay, so in other words, on this logarithmic scale, we have to take 2 steps to the left in order to get to 1/9. So the log base 3 of 1/9 is, can you guess? Yeah, it's -2. Okay, so we can write the log base 3 of 1/9 is equal to -2. Okay, so again, the merit of the log system is it's telling you the base, it's telling you where, and then it's telling you where you want to end up, and it's saying how many steps and in which direction do we have to take to get there. Okay, so another way, if you don't want to use the scale, we could simply, at the very beginning, we could rewrite this as 3 to the x power is equal to 1/9. Okay, again, we're either multiplying or dividing by 3, right? We multiply as we go to the right, we divide as we go to the left, and again, the result that we're seeking, right, this is our result, is 1/9. Okay, so we're saying how many steps do we have to take to the left or the right to get to 1/9? All right, let's do one more example like this. So now we have log base 1/2 of 4 equals x. Okay, so remember, as soon as I have my base is 1/2, right? This is my base. As soon as I have that, I can go ahead and fill in this number line. So let's take a minute and do that. Feel free to pause the video and do this on your own if you want. That's a 2. Okay, so anything to the 0 power is 1. So this is 1/2, 1/4, 1/8, 1/16. Okay, going in the other direction, we have 2, 4, 8, 16. All right, so we have our scale filled in, right? And then remember the 4 tells us where do we want to get to? Where do we want to land? Okay, so where do you see 4 on our scale? Well, it's right here, isn't it? Right? So we know that log base 1/2, oopsies, base 1/2 of 4 is equal to, how many steps do we have to take and in which direction? Well, we had to go 2 steps to the left. So we have -2. Okay. Again, a shortcut method to understand this, we can always rewrite it in exponential form. Basically, we're saying 1/2 to the what power is equal to 4. Okay. And again, the answer is -2. So let's practice converting from exponential to logarithmic form. So over here, we have something in exponential form. So we're going to write it as x is equal to b to the y. Okay, and we can rewrite it in logarithmic form as log base b of x equals y. Okay, so let's map these functions, right? So the base here becomes the base of my log over here. Okay, so let's start with the first question. It says 2 equals 10 to the x. Okay, let's find our base. What is our base? Well, our base is 10, isn't it? So I can start by writing, on the right-hand side, I can write the log base 10. Okay, again, this is my base here. Okay, this is my base over here. Okay, so what should we explore next? Maybe we should look at our exponent. Okay, so our exponent is y. So where should y go in our log? Well, it goes on the other side of the equal sign. So over here, I'm going to write log base 10. I'm going to leave a space, and then I'm going to write equals. And what is my exponent? Let's write it out here. Right here's my exponent in my exponential form. So it must be x. Okay. Then last but not least, right, we have our result, right? The result of b to the y is x, right? It is the argument of our log function. You can remember that or not. It's up to you. Okay. So then what is that value here, right? It is 2, right? So 2, this is my result. It is the result of raising 10 to the x power, okay? And my result goes over here, okay? So really quickly, before we move on to the next question, if you're wondering, why are we doing this? Why are we going through all of this? Well, if you look at your calculator, you'll probably find a log function on it. Okay, so I could literally type in log base 10 of 2 into my calculator, or the log of 2 into my calculator, and get an answer. Okay, so the reason we go through all this work and effort and energy is because log is a function, it's programmed into your calculator, we can compute the result. Okay, all right, let's do the next question. It says m to the 3rd power is equal to 5. Okay, so let's start by finding our base. Our base is m, so we're going to have log base m. Okay, again, that is our base. Okay, then we have our exponent. Our exponent is clearly 3. Okay, and remember when we write our log function, the exponent goes on the other side of the equal sign. Okay, last but not least, we have our argument, or what I like to call the result, right? It's the result of raising m to the 3rd power. Okay, and that nestles right in there. All right, let's do another example. We have 7 squared is equal to b. Okay, so as you can see, our base is 7. So we have log base 7. Okay, we have our exponent. Our exponent is 2. Remember, the exponent goes on the other side of the equal sign. And then we have b. It's kind of an unfortunate choice of variable, right? Because b usually stands for base. Oopsies. Probably shouldn't have done that. Oh well. But in this case, b is just our result. So we have log base 7 of b equals 2. Okay, and then last but not least, we have 2 to the 3rd power equals 8. And we already did this example before, so I'll just do it really quickly. Okay, so we have log base 2 of 8 equals 3. Okay, so now what we need to do is we need to go the other way. We need to go from a log function to an exponential function. Okay, so notice that whatever our base is for our log becomes the base of our exponent. Okay, whatever is the argument, or you could call it the result, right, is going to be on the other side of the equal sign for our exponential function. And then our exponent, this y, goes right here. All right, so let's practice. So the first thing I always try to find, because it's the easiest thing to find in both exponential and log form, is the base. Okay, the base is 4, so I'm going to have 4 here. Okay, where is the exponent? Is it 16 or is it 2? Take a minute, pause the video, and see what you think. Well, the exponent is y, so it's this 2, isn't it? It's the number on the other side of the equal sign, right? And where does that go, right? The 2 goes up here, right? It becomes the exponent of 4. So I have 4 squared equals 16. So that is the answer. So this is kind of tricky because if you think about it, 2 to the 4th power is also 16, okay? But that is not our correct answer. Why is it not the correct answer? Because 2 is not the base and 4 is not the exponent. So just be careful a little bit with that example. All right, let's keep going. So what is the base here? The base is 3. Okay. Where is the exponent? Well, the exponent is over here on the other side. Okay. So we have 3 to the 7th power equals something, right? And this is our result. Of course, you could just type it into your calculator, right? 3 to the 7th power, and you would find out what that is. Okay, but again, we're not interested in finding the result. We're just practicing the skill of going back and forth between expressing something in log form and exponential form. All right, let's keep going. So our base here is 9. Okay, over here on the other side is our exponent. So 9 to the 1/2 power equals, right, 3. 3 is our result. Okay, last but not least, our base is 5. Okay, that is our base. Okay, over here, -1 is our exponent, right? So we have 5 to the -1st power, and the result is 0.2. Okay, let me rewrite this. It looks a little bit weird. 9 to the 1/2 power. Okay, so in the last 2 slides, we have converted from exponential to log form, and we've gone from log to exponential form.